This video is about dilation in geometry. Dilation can be done according to the origin or with relation to the origin, which is 0, 0, or it can be done with a relation to a point not the origin, some point A, B. And for 0, 0, I'll dilate it by a factor of k. If k is bigger than 1, then it's an expansion. It goes whoop. And if k is less than 1, it's a contraction. It goes whoop. So whoop for bigger than 1, whoop for less than 1. So let's say I have, and this is how it works. If I have a point x, y, and I dilate it by that k factor, it's going to be kx and then ky. I just multiply the x and y by k. I will give an example. Let's say I have a point that's 4, 2, and I'm doing a dilation with relation to the origin of 1/2. And so the new point is going to be 1/2, 4, 1/2 times 4, and then 1/2, the y coordinate is be 1/2 times 2. And it's a because it's contracting. 1/2 times 4 is 2, and 1/2 times 2 is 1. So I'll show this on Desmos just so it can be visualized. The original point is 4, 2. I'm dilating it with respect to the origin by a factor of 1/2, so it's a contraction. It becomes 2, 1. And you can see, check it out, how that point, let me go home here, that point is like halfway to the origin. Here's the origin, and it's halfway to. Now if I had a triangle or something, you'd see that triangle shrinking with a 1/2. And I'll show that, well, you know what, let me show that with this. Let's say I had 4, 2, I had 6, 4, and then I had 10, 3. I'm going to do all 3 of these points, and then I'll do them in relation to a different point. So xy becomes kx, ky. So 1/2 of 6 is 3, 1/2 of 4 is 2, 1/2 of 10 is 5. Oh man, I used an odd number. 1/2 of 3 is 1.5. So let me put all of them. 6, 4, 10, 3. These are the original points. And then I have 3, 2, and 5.5. And so you can see, let me put these, 4, 2 was A, whoops, A, I want to label this one, 2, 1, is that, wait a minute, no, that's the new one, so that's A prime. And then this is B. B was 6, 4. I'm labeling them so I can see them. And then C was 10, 3, I think. And then this is B prime. And this is, I didn't want to add a slider. I wanted to do a label. This is C prime. And you can see, here's the original triangle, A, B, C, and here's a new one. It just got smaller, and it's going towards the origin. Because I'm just multiplying them all by 2. And you'll notice that the distance from A prime to B prime is half the distance from A to B. You can measure it if you want to. And B prime to C prime is half the distance from B to C because it's shrinking it. It's a dilation of 1/2. So 4, 2 became 2, 1, 6, 4 became 3, 2, 10, 3 became 5, 1.5. Now, what if it's a point AB instead of the origin? And this is not difficult. XY, if it's dilated by a factor of k, and I'll use those same original points, but I'll use a different point than the origin, it becomes this. The x coordinate is k, x, oh, and let's say it's about the point AB now. So it's k, x minus a plus a, and then k, y minus b plus b. So this is the new x coordinate. This is the new y coordinate. I just take k, the dilation factor, multiply it by the difference, x minus a, x the original x coordinate of the point, and then minus a, the x coordinate of what I'm dilating it according to, and then add the a of what I'm dilating according to, and then same thing with the b's. So let me do all of these. I'll do 4, 2, I'm going to use a different point, 6, 4 and 10, 3. But this time, so this is point A, B, C. This time I'm going to do K equals 3. And the point I'm going to dilate it according to is 3, 7. All right, so let me get rid of these extra points here because, what was it, 10, 3? That's ABC. And then this is, I'll call it the point of dilation, is 3, 7. 3, 7. And that's going to be the point of dilation, POD. And so now this thing is going to get bigger by a factor of 3 because K is bigger than 1, so it's an expansion. It's going to go whoop. So let me see. I will do these formulas. K, which is 3, times the x-coordinate of the point, 4, minus the x-coordinate of the point I'm dilating it according to, so minus 3, and then plus 3. And then the y-coordinate, whoops, I want to put a comma there. The y-coordinate is K times y, which is 2, minus b, this is AB. These are the xy's, the points. So 2 minus 7, and then plus 7. And I'm going to need more room. I always need more room. So I can write the answer to these things somehow. I guess I'll just make it bigger like that. And this is going to be 4 minus 3 is 1. 3 times 1 is 3. 3 plus 3 is 6. And then this is 2 minus 7 is negative 5. 3 times negative 5 is negative 15. That should be a 7. Negative 15 plus 7 is negative 8. And then this one is going to be, again, the K times 6 minus 3 plus 3, x minus a plus a, comma, and then it's the K times y minus b plus b. And so that one's going to be 6 minus 3 is 3. 3 times 3 is 9, plus 3 is 12, comma. 4 minus 7 is negative 3. 3 times negative 3 is negative 9, plus 7 is negative 2. So that's my next point. And then for this one, it's going to be 3 times 10 minus 3 plus 3, comma, 3, the K factor, times 3 minus the b, minus 7, plus 7. And so that point's going to be 10 minus 3 is 7, times 3 is 21, 22, 23, 24. My goodness. And then this one is 3 minus 7 is negative 4. 3 times negative 4 is negative 12, plus 7 is negative 5. So now I'll put these points in just so I can see them. This is 6, negative 8, and that one I'm calling A prime. I'm labeling them just so I can show them. 12 minus 2, that's B prime. All the work is done now, I'm just visualizing it. And then I get 24, oh my goodness, 24 minus 5, that's C prime. Remember, this was an expansion because K was bigger than 1, so it's whoop, and I can see this. So see here, A, B, C, and there it is. It's whoop, getting bigger and bigger as it moves away from the point of dilation. So that's how it's done. K times x minus a plus a, and K times y minus b plus b is when I want to dilate it in reference or with relation to a point AB. And that's it.